Kotlin 1.8.20 introduces the newest multi-platform compilation target for Kotlin, which is WebAssembly. And that one opens up a bunch of new possibilities for us Kotlin developers, ranging from writing functionality for web apps to running server-side with Node.js and even bringing your Compose apps to the browser. There's a whole bunch of exciting things to dive into, and that's exactly what we are gonna go and do today. We'll take a look at WebAssembly as a technology, talk a bit about the current state of Kotlin Wasm, how you can get started yourself, and what the future holds. Very simply said, Kotlin for WebAssembly is a new compilation target for your Kotlin code that targets modern browsers. Actually, you'll be able to go even beyond the browser, but more on that in just a little bit. Basically, you can think of WebAssembly as a binary instruction format for a portable virtual machine. And it's not just any new experimental technology, it's actually standardized by the W3C, the World Wide Web Consortium. It's similar to other virtual machine languages in that it is a platform-independent bytecode format, and it's really been designed as a compilation target for other programming languages, like Kotlin, and actually a number of others like Rust, Go, and C#. Now, one of the best parts about WebAssembly is that the virtual machine that you need to run Wasm code comes built into all modern browsers. That means users don't have to manually install or download anything extra just to run your code. But this also goes beyond the browser, with Kotlin for WebAssembly already supporting Node.js as an execution target as well. And with the future support for WASI, the WebAssembly system interface, Kotlin for WebAssembly will also be able to interact with the operating system directly, for stuff like making system calls when running in standalone WebAssembly runtimes. And that opens up another set of doors for Kotlin, like lightning-fast startup times in server-side and serverless settings. And one of the parts that's really awesome about WebAssembly is performance. For Kotlin, that is actually multi-dimensional. The team wants to provide good and predictable execution speed for your Kotlin Wasm programs, and also make sure that the bundle sizes are small so that you add as little extra weight as possible to your web apps. And of course, the experience for you as a developer is also important. So the team is actually building the compiler backend for the Wasm target from scratch so that there's a solid base for the best compilation performance possible. And all of that is being worked on as we speak alongside other quality of life work, like working on good debugging support and topics like incremental compilation. And while some of these things are still in the future for Kotlin, we can already go hands-on with the current experimental version of Kotlin for WebAssembly and explore. So what's the easiest way to get started with Kotlin for WebAssembly? Well, you can just grab yourself a copy of the examples repository, which we have linked you down below. And in here, you can find a bunch of different samples that you can check out. We can actually take a closer look at each one of them individually, and we'll just start with the most basic case and work our way up there. But of course, after you've finished watching this video, I very much encourage you to play around with them yourself. So since these are 4 independent projects that are in here, we are going to start with the most basic one, which is the browser example. Before we even take a look at the basic code, let's see what this thing actually has in store for us. Just like many other Kotlin projects, we can run this using a Gradle task. In our case here, it's called Wasm browser run. And that is going to compile everything. And after just a couple of seconds, we will see our example application open up. And we see that it prints a hello world string, but of course it does this using WebAssembly. This browser does have a little bit of extra configuration set up for it. Specifically, it has the WebAssembly garbage collection flag enabled. That's because Kotlin for WebAssembly builds on some of the newer WebAssembly proposals. They are either set by the user using a feature flag like is done here, or they can be set on the server side using the so-called origin trials. But in the near future, when these features are stabilized, you'll just be able to plug your Kotlin for WebAssembly code in a website, and it'll just work out of the box. No extra configuration required. Great. If we were to continuously make a couple of changes, we could of course also change this configuration and use Gradle's continuous builds. So we could use the -t flag to automatically re-execute the requested tasks, which means that any changes we make, we will see immediately. So if I were to go into our Kotlin code, which we'll look into in just a second, and I were to make a change, like for example, change the hello text to howdy, then you'll see that automatically the page in the background was reloaded, and it now says howdy world. Very cowboy. All right, there is a couple of things to talk about in the Kotlin code itself, but I think it's maybe first a little bit interesting to look at the build file for this project as well. So as you can see, this project just uses the Multiplatform Kotlin plugin, because Kotlin for WebAssembly is just another Kotlin multi-platform target. That also means that setting it up is quite simple. There's a couple of specific things here that enable the dev server, but apart from that, you can see a pattern that is quite typical here. So in the Kotlin block, we specify our Wasm target. We say that it's supposed to generate executables. And alongside our common main and common test source sets, we also have a Wasm main and Wasm test source set. In these, you would, of course, then typically also specify, for example, your dependencies block if you had any extra dependencies that you wanted to use just for WebAssembly. So there's already a bunch of libraries that work. The Kotlin standard library, probably the first and foremost. Kotlin test also works, and there's also artifacts for Kotlin X benchmark. There's a couple of other Kotlin X libraries that you're probably looking for, such as Kotlin X coroutines. That's currently still in progress. If you want to see the full list and full status, go to kotlin.in/wasm. We are also going to make sure that that is linked down below. Okay, so I think it's time we actually look a little bit at this Kotlin code right here, which hopefully doesn't look too strange for you. Because Kotlin for WebAssembly actually has the goal to make it seamless for you to use web APIs directly from your code. So the standard library actually provides the same Kotlin X browser APIs or the Kotlin X DOM APIs that you may have already seen in Kotlin.js, for example. So you can manipulate DOM elements and use all the capabilities that are usually available in the browser. So for example, if I were to take our wonderful page here and I would take a look at the body's style property and I would set the property background color to be red, and I make sure that I respect nullability, and I move on over here, we see a wonderful red page now. So we can pretty much build our whole web app in Kotlin for WebAssembly and still easily access things like the DOM directly from the Kotlin APIs. So we can actually take a look and see what the browser actually executes here. If we move to the Sources tab, we can see that there's a Wasm file. And this is, of course, our compiled Kotlin program. Kotlin Wasm also generates the required glue code that bridges the worlds of JavaScript and WebAssembly calls. Because you might know this, it's usually not that trivial to make, for example, DOM manipulation out of WebAssembly. But Kotlin Wasm does this in a way where you don't really have to think about it, and all of this is provided to you out of the box. We don't have to look at this from the browser, of course. We can also simply see the files that were generated by going to our build folder and navigating to our browser example Wasm, where we see the Kotlin folder in which we can see these 4 different files that relate to our project. The source maps, a module declaration that allows this whole WebAssembly module to actually be imported from the JavaScript side, as well as the actual compiled WebAssembly file. So whether it's making requests or manipulating the DOM, all of this should feel very natural for you from Kotlin for WebAssembly, pretty much straight out of the box. But of course, you might not want to write your whole application in WebAssembly. And instead, you might just want to write a small part of your app in Kotlin Wasm, then package that nicely into its own module, and export a certain set of functionality to the JavaScript or TypeScript ecosystem. And we can actually do that as well. So let's say we have a wonderfully complex function called add, which takes 2 integers and just returns their sum. If I want to make this declaration available from the JavaScript ecosystem to be used, I can use an early version of the JS export annotation. If you have written Kotlin JS before, this one might be familiar to you as well. Very simply said, the JS export annotation just instructs the compiler that this declaration below it should be exported to the JavaScript world. Keep in mind that since the WebAssembly target is still experimental, JS export might not work for more complex structures that you have built, but for basic things, it already works. Great, so now that we have instructed the compiler to do that, we can actually go into, for example, a JavaScript file, and from here we can then use this module. I already have a small snippet prepared for this here, so this is just the import statement that uses the module declaration that we actually saw beforehand to import our module. And then from there, we could do something simple like log the output of my module.add, and we'll add 1 and 2. So after adding the from ES6.js file to our actual index.html and then just reloading the page, we can see that we indeed get 3. So there's a basic level of interop for you available as well. But as we alluded to beforehand, the Kotlin WebAssembly journey doesn't end in the browser. We also have support for Node.js. So in this case, I've just opened the Node.js sample. And just like beforehand, we can use this time the Wasm node run Gradle task to execute our little application here. And after a short second, we'll see the actual output of our Node.js file. And once again, if I were just to write some very basic Kotlin code in here and were to rerun this, then you would see the appropriate output directly, which is quite exciting if you're considering WebAssembly for a server-side or serverless context. Once again, when we take a look at the build file, we can see that the Node.js target is also just a configuration of the Kotlin Multiplatform Wasm target. Nothing special going on here either. Well, that's pretty much all you need to know to get started. So, we've already seen it with the Node runtime. WebAssembly gets pushed beyond the browser because it provides a fast, scalable, and secure way to run the same type of code across all kinds of machines. But Node.js is still a JavaScript runtime on some level, and things go beyond that as well, with standalone WebAssembly runtimes like Wasm Edge, Wasmer, and Wasmtime. Those are also increasing in popularity. In fact, Docker already has beta support to run Wasm binaries as an alternative to Linux or Windows containers. You can check that one out if you're interested. Now, such code that lives outside of a browser needs a way to talk to the system to do things like access files and sockets, for example. The WebAssembly System Interface, or WASI for short, does exactly that. It's an operating system independent interface that allows you to make low-level system calls right from WebAssembly. WASI itself is still experimental, but there are already some experiments ongoing to see how the functionality can be used from Kotlin. If you're interested in learning more about this, check out the Co-Wasm project by Seb Deleuze. He also has an article detailing more about the potential and possibilities that Kotlin WebAssembly brings with it. I really strongly encourage you to take a look. It's a great read. We're also experimenting with Compose Multiplatform, the declarative UI framework we're building for Kotlin, and how it could use Kotlin for WebAssembly to perform pixel-perfect, canvas-based UI rendering in the browser, and taking shared user interfaces one step further. Let's take a closer look. Here's an application built using Compose Multiplatform. If you're an Android developer, you may actually have seen this specific example before. Now, as you may know, at JetBrains we're working on bringing Compose Multiplatform to a bunch of different targets beyond Android, like desktop, iOS, and web. Now in practice, that means you can take any knowledge that you already have about the APIs of Jetpack Compose, from developing for Android for example, and you can use it to target other platforms. In our case, through the power of Compose Multiplatform, we can take the same app that you just saw running on Android and run it here in Google Chrome. And it actually looks and behaves just like we saw on Android before. We can also take a quick look at the performance of this app. So we can open up the FPS counter in Chrome's DevTools and watch some of these beautiful animations as they move along. We're also working on making it possible for you to debug Kotlin code right inside your browser and inspect variables and stack traces in the developer tools using built-in support for source maps. Although these are still at an early stage right now. We actually first showed Compose for Web at KotlinConf 2023 during the keynote, and it actually got featured at this year's Google I/O as well, when the Chrome team was talking about WebAssembly as a new development paradigm for the web. If that sounds interesting to you, you might want to check that video out as well. We have that linked, of course. It talks about a lot of exciting stuff going on in the WebAssembly ecosystem as a whole, and it also takes a closer look at the Kotlin case in particular. Plus, you might see some familiar faces there as well. So, what's next for Kotlin for WebAssembly? Well, it's probably not surprising to anyone, but we want to make things better. There's a number of topics that are already being tinkered on. We already talked about making it work outside the browser in dedicated WebAssembly virtual machines, and we briefly talked about WASI, the WebAssembly System Interface. There's also another thing, the WebAssembly component model, that goes hand in hand with this topic because it will be the thing that enables interoperability between different WebAssembly modules. So there's work to integrate that as well. And of course, we want to make things more performant. With incremental compilation and some other optimizations, we want to make sure compilation times are the best they can be. Wonderful. I think it's your turn now. It's still early for Kotlin for WebAssembly, but that makes it a great time for your own first experiments with the tech. And of course, to just have a closer look. We have all the getting started information summarized at kotl.in/wasm, which you can also find down below in the description. From there, you can start exploring the examples and run your Kotlin WebAssembly code in the browser, in Node.js, together with Compose Multiplatform, and beyond. If you're a library developer, it'd be especially awesome for you to take a look at this new target, see what it might take for you to support it, and start targeting Kotlin for WebAssembly with your libraries. And of course, we really look forward to your feedback on the typical channels. As usual, if you want to chat with any of the developers working on or with Kotlin for WebAssembly, we have a dedicated channel on the Kotlin Lang Slack where you can ask your questions, get help, or just hang out with a couple of other WebAssemblers. We'd love to have you as a part of the community and see what you build with this first experimental version of Kotlin for WebAssembly. If you want to get an even broader picture of Kotlin for WebAssembly, there's two more talks that I can recommend that you check out. There's the Introducing Kotlin for Wasm talk by Salim and Sebastian. Salim leads the Kotlin Wasm team at JetBrains, and we briefly mentioned Seb before when we talked about CoWasm. And he also gave another talk at KotlinConf, Scale to Zero with Spring and GraalVM or WebAssembly, which you might also be interested in. Both of those are linked down below as well. Well, that's it. I can't wait to see what you'll build with Kotlin for WebAssembly. I'm sure it'll be awesome. Thanks for tuning in, and have a nice Kotlin. Take care, everyone.